Hey everybody. Before we left for break, we were working on permutations and combinations, and I wanted to go over that one more time with you guys before we get to after spring break when it's going to be time to teaching you guys new stuff. So I wanted to try and record a video lesson before it was a new stuff record video lesson time. Our permutations and combinations work revolve basically around telling the difference between the two, as well as setting up their equations at first. So both equations use the factorial notation, which is that n with an exclamation mark, pardon me. N factorial is equal to itself times the number that came before it times the number that came before that times the number that came before that, on and on, timesing till you get down to 1. So our formula for permutations went that P stands for permutations of n, choose R. N's the total amount of things you have. R is what you want to choose, the amount that you want to take out of that, is equal to n factorial over n minus R factorial. Oh yeah. Whereas combinations was C of n choose R. And that formula went n factorial over R factorial times n minus R factorial. The differences in these guys can be seen pretty plainly once we throw some numbers in here. If I'm working with P of, say, 6 choose 2, the 6 factorial is going to go up on the top of my fraction, and on the bottom I'm going to have 6 minus 2 factorial. 6 minus 2 is just 4, so that's really 4 factorial on the bottom. So this whole thing is really 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. And like we talked about while we were in class, the 4 factorial on the bottom is telling us, it's screaming at us, that we're going to end up canceling out everything that's 4 and afterwards. So the number of permutations of 6 choose 2 is simply 6 times 5, which is 30. Now combinations are a little bit different, not a lot of it. It's still going to be C of 6 and 2. We're still going to have our 6 factorial on the top, but now we have a 2 factorial in front of that 6 minus 2 factorial. Once again, that 6 minus 2 factorial is going to bust down into 4 factorial. So written all the way out, this looks like 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1 times 4 times 3 times 2 times 1. Oh yeah. We're going to bust down those 4, 3, 2, and 1 again, even though we don't really need to cancel out 1s. And then we still have a 2 and a 1 on the bottom. So this 2 and this 6 are going to cancel. You're left with 3 times 5, which is 15. Which is the big deal with these two things. You get 2 different answers. So when do you want to use which? We want to answer this question. When to use which? And the big answer is permutations are for when order matters. In just a second, I'll go over exactly what that means, that order mattering. But in a shorter kind of way, it means that we're going to get more options. Versus with combinations, order doesn't matter. Anarchy. And it limits your options. So, not a word problem per se, but just like a situation. Say I have 6 sodas to choose from. Let's name them. Let's go with some Pepsi, Sprite, Diet Coke, just in case you're weight conscious, Fresca, just in case you're like my dad and fresh out of jail and all you want is a grapefruit flavored soda, Dr. Pepper, my favorite, and Flart. What's that? You've never heard of Flart? What are you, an idiot or something? Everybody knows the delicious taste of Flart. Anyway, as I was saying, In a permutation, order matters. So if I want to choose two, then I could take, say, Pepsi and the smooth refreshingness of Flart. Or I could take Flart, smooth and refreshing once again, and Pepsi. And these are two different options because I chose Pepsi first this time and I chose it second that time. That distinguishes it, first, second. In combinations, it doesn't work that way. Pepsi and Flart is the same thing as Flart and Pepsi. You only get one choice. So in this case, you had two options. Over here, you only had one. And that's what's limiting your choices. It's cutting out those duplicates, or it's telling you that order doesn't actually matter. I've got some word problems that I would like you to try now. And our job with the word problems will be, first of all, to identify whether it's permutations or combinations. And then once that's identified, to actually figure out the problem by using the correct formula. You'll be able to pause the video in the middle of it because I'm going to read them, but I'm going to read them only a brief pause, and then I'm going to move on to the next one. So you want to pause the video so you get a chance to work it through, and I'm not just steamrolling over you, so to speak. Hold on just one moment. Still working this program out. I thought I had it smooth. All right. So I will read them to you. You're going to pause them. You're going to figure out what type of thing it is, whether permutation or combination, and then you're going to find the actual value, the amount of choices. So the first one, a typesetter is placing letters into a printing press to make Mr. Beale's old-timey book. She has 12 letters in her hand and needs to make the word the. How many different ways can the letters be arranged? Next one, Mr. Beale is judging a baby beauty contest and decides that each baby is disqualified. 4 of the parents protest, to which Mr. Beale says that they are disqualified from life. He pulls out 4 of his 9 distinctly colored throwing knives he has in his pocket. How many different variations of the 4 knives could there be? Mr. Beale, the judge, has a full docket of cases to choose from, including some whose statutes of limitations may expire in the middle of his court proceedings, if he's not careful. If there are 10 cases to choose from, and he can rule on 6 cases a day, how many different variations of cases for the day are there if he chooses by random? And finally, Mr. Beale is running in a seniors-only 2K fun run on a bun, where anyone who finishes the run gets to pet a fish named Lucky. If there are 20 runners, including Mr. Beale, how many different versions of the top 3 runners, which will likely not include Mr. Beale, could there be? All right, guys, if you are done pausing and working out these problems, I can go over each of them with you. Just let me switch my screen up, which has been kind of an issue. All right, all the way switched up. The typesetting problem. This problem is definitely an order matters problem because you're trying to make the word the. And if you were to get all of those letters, but you don't get them in the right order, it wouldn't count. So we were working with P of 12, choose 3. This would be 12 factorial over 12 minus 3 factorial, which is to say that we're going to be cutting off everything that is 9 and below. So this is just going to be 12 times 11 times 10. Now I know what you're thinking, Mr. Beale, that's not enough work for me. I still don't know what's going on. Also, I hate you. Hey, you're a long way away from me now, so I guess that makes you safe. But anyway, don't worry about it. I'll write out the problem for you. I'm just adding in that stuff that would definitely be canceled out because you are some kind of jerk who needs me to do that. Pew, 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 whee! 12 times 10 times 11. I don't really know what that is. Oh, wait a second. It's not like 1,320. Way to go, math brain. Bam. There's your number of options. Good check. All right. Mr. Beale is judging a baby beauty contest. He sure is. In this case, Does it matter for the order? And the answer is no. Just pulled out these throwing knives. They have different colors, but there's no special power associated with them. At least it doesn't say so in the problem. So we can assume that order doesn't matter, and we can use C instead of P. This will be C of 9 choose 4. That'll be 9 factorial over 4 factorial times 9 minus 4 factorial. Now I might have messed this up something fierce because I think this will have a whole bunch of numbers in it, and I didn't do it out ahead of time. So let's see how this works. I'm trying not to cry too much. 4 times 3 times 2 times 1 times 5 times 4 times 3 times 2 times 1. Just be where that 5 come from. 9 minus 4 is 5 factorial. Come on now. All the way canceled out those guys. This 4 will go into this 8 twice. This 3 and this 2 will eliminate that 6. Looks like it's going to be, I don't know, 7 times 9 makes 63. 63 times 2 should be 126. Glad that worked out. Like I said, no calculator. Mr. Beal, the judge. This case we are dealing with is permutations. Why does order matter? Well, because some of the cases may expire before he gets to them. So it does matter when you do what. 10 factorial over 10 minus 6 factorial. Well, this one looks like it's going to be super nice. Wait a second. 10 factorial over 4 factorial. I'm just cutting off the 4, so that's 10 times 9 times 8 times 7 times 6 times 5. I am not prepared for this. My phone is right next to me, though, so let's use that. Technically, we're not in class, so I can't get in trouble for this. I guess you guys can't get in trouble. Well, you might even be watching this on your phone. I don't want to think about that, okay? Whoo, jeez. I got 151,200. I feel like that's right. You guys are definitely going to need to check that, though. All right, Mr. Beal's running in a seniors only 2K fun run on a bun. Yes, I am. In this case, order doesn't matter. Everyone gets to pet the fish so long as they finish. This would be 20 factorial over 20 minus 3 factorial. As well as in front, let's see, order doesn't matter, so there will be a sweet 3 factorial in the front. So we have 20 factorial over 3 factorial times 17 factorial. So this is what I was getting at, guys. I speed myself up in doing this, not by throwing this stuff into a calculator, which you can do. There's calculator functions for it. But this is telling me 17 and under, cut all that stuff off. So the top is just 20 times 19 times 18. Ooh, I'm looking at that with quite a bit of trepidation. Over, that means the 17 factorial is gone now. I've chopped that off. All I've got left is the 3 times 2 times 1. 3 and 2 will go into 18. Let's see. I think there's going to be a 3 left over. 3 times 2 makes 6. 18 divided by 6 is 3. And then we got to times that out. 60 times 19. Do that on paper. 0, 54, 0, 0, 6. Looks like it's 1,140. Oh, yeah. Hot potato. I'm going to assign you guys some work with this. It'll be CUDA work, so the problems won't be as absolutely fantastic as you are used to, but they'll still have this theme going. Can you tell the two difference apart? And can you solve the problem? Thank you very much for joining me today. It's been great. Bye.